from the University of Toledo, and this is, I guess it's our 7th webinar for the year. I always like to start off with the basics here. So let's see if I can do that. All right, so our guest tonight is Bruce Anderson. He's a professor at Boston University. He's been working on Globe Mission Earth as a subject matter expert. We call them SMEs, NASA calls them SMEs. And just to give you a background for Globe Mission Earth, it's a partnership between the University of Toledo, Boston University, UC Berkeley and Wested, Tennessee State, and NASA Langley. And basically, well, we're funded by NASA to bring Globe and NASA assets to basically K to 16 or beyond. You know, get people doing projects using Globe, and then introducing NASA satellites and other materials. Just to mention, we will have a student follow-up webinar on Friday at 1 o'clock, and here's the link to call in. And I'll stop sharing and then turn it over to you, Bruce. Oh, you might be on mute.
Yep, there we go. So I will start by introducing myself. I'm Bruce Anderson. As noted, I'm at Boston University. My subject matter is weather and climate, as well as oceanography. But I'll be talking to you today about use of globe measurements for what we call local weather forecasting, and how you can put this into practice in hopefully your own classrooms to some extent. So I'll just start my presentation. Now, oh, that is what I want. Yep, sorry, just getting a hang of this. And I will start from here. There we go, perfect. So I am going to be talking about local weather forecasting using globe observations. If I can minimize this. Nope, I can't minimize it. Sorry, guys. I'll put it over here. You'll see that there is a local weather station. It's more well-equipped than yours, probably. But effectively, you can take many of the measurements that they will be taking and use those to actually have your students make predictions. It is not, I guess I have to do this with the next page. There we go. So I will start with some text. We know that weather and its day-to-day changes are actually omnipresent in children's lives. They experience it every single day. Is there any way to get rid of that? There we go. And in fact, by observing weather and its day-to-day changes, students can do many things. They can start to interact with their environment, but they can also start to take measurements about their environment. Ultimately, as I hope to show you, they'll start to be able to make predictions about their environment. And eventually, after going through the process of taking globe measurements through the sort of vertical integration from kindergarten all the way through grade 16, they're going to get to establish some deep knowledge about the environment in which they live, but also the standards which the educational community has set for them. Sorry, I have something. So what we want to talk about today is how measurements made as part of GLOBE protocols can help students in all of these endeavors. And to start, we're going to actually have to recognize what generates weather in our region. And for every place sort of north of Florida and north of Texas and Arizona, the principal weather generator for our area is what we call traveling cyclones. And cyclones are low pressure centers around which air starts to move. And so these things are massive. They compass entire half continents in this case. So here would be a center of low pressure, and there is going to be spiraling air moving around this low pressure center. And as that air moves from one region to another, it starts to influence the regions it's moving into. And so the key to understanding how these low traveling cyclones or these low pressure centers generate weather is to understand how they induce movement of this air across continents and what happens when air moves from one region into another. And so I am going to go through that process. And as we go through that process, we'll learn something about the weather phenomenon that accompanies the movement of these air masses from one region to another. And so, in fact, by the end, we'll actually see a very prototypical storm system that's about to hit the East Coast that looks very much like this one. So let's start with the basics. Here is an idealized image of a low pressure center situated right here. I'll put the pen back on. That is a low pressure center. The lines are called isobars. They're measures of or lines of equal pressure. The units are millibars or hectopascals. So as we move away from this region, we go to 1005 millibars, 1008, 1014. So this is the region of low pressure. And the thing to recognize is that as these low pressure centers develop, in fact, what you end up getting is air moving around those low pressure centers. And very typically in the northern hemisphere, air circulates counterclockwise and into low pressure centers. And so that circulation is identified by these arrows here. And so what we get is this counterclockwise circulation moving, spiraling air into these low pressure centers. And as they do so, they start to induce movement of air masses. Air masses are large bodies of air spanning hundreds of kilometers that have fairly uniform temperature and moisture characteristics. And so, for instance, these low pressure centers tend to move from west to east. So in this case, this would be out ahead of the low pressure center. We would find the winds moving from east to west. Those are called easterly winds. Now in our region, most typically the winds blow from west to east. So one of the first signatures, and we'll talk about this, of an approaching storm is a reversal of the wind fields from westerlies to easterlies. Now, to the south of the low pressure center down here, we have what we call southerly winds because they're moving from the south. And because they're coming from the south, the air that's moving with them tends to be relatively warm. It also tends to have quite a bit of moisture. And what you find is that this warm air tends to move northward into regions that are relatively cold. And what we get is a intersection between the relatively warm air moving from the south and the relatively cold air that it's moving into. And that area of intersection is a front. And this is a warm front designated by these half circles. And we'll talk about that in a little bit. Now on the backside of the low pressure center, we have air coming from the north. So they're called northerly winds. Now, because the air is coming down from the north, very typically it's cold. Sometimes very dry. As that air moves into the locations down here, there is again another region of intersection, again called a front. Because it's the cold air that's moving, this is called a cold front and designated by these arrows. So now we have a sense of the horizontal movement of the air around the low pressure that in turn induces the movement of these air masses with different temperature and moisture characteristics. But to really understand the weather that accompanies these moving air masses, we have to look at them from the side. So this line from A to A prime is going from here to here, but now in this direction is the vertical direction, not the horizontal. And so if we were looking out here at the warm front, what we have is warm air approaching from the south. That's this line here. Now, once it intersects with the cooler air, it continues to move to the north, but because it's warmer, it's less dense. And because it's less dense, it starts to rise up over the colder air below it. Now, one of the most important things to recognize is that as air rises, it starts to cool. And the reason it starts to cool is the pressure around it starts to decrease and the air mass starts to expand. So the equivalent of experience for children maybe, or for yourselves, is to let air out of a tire or out of a pressurized can. It will always feel cooler because it's expanding. And that exact same thing is happening to the air as it rises. Now, because it's cooling, it has water vapor in it in the form of gaseous water. The ability for air to hold water in the gaseous form as water vapor is temperature dependent. The colder the air, the less water vapor it can contain. And so as the air rises and cools, eventually some of that water vapor has to condense out, and that's when we start to form clouds. And so what we find is that one of the first indicators, besides the changing wind direction of an approaching storm, is cloud formation. Now, the very first clouds, the highest clouds, are these cirrus clouds. These are clouds that are fairly typically high up, but also fairly flat. These aren't these billowy cumulus clouds. They're instead types of stratus clouds. And so out ahead of the warm front, we tend to find cirrus clouds where the air has risen the highest, but behind it, we start to find these layered clouds, altostratus. And behind that, if the clouds are fairly thick, we still have layered clouds, but now if there's rain associated with them, they're called nimbostratus. And so in fact, we would find the rain falling out ahead of the warm front, and that's what's indicated by this gray region here. So that's one of the first indicators of an approaching warm front, is these layered clouds, first very high up in the atmosphere, cirrus, then altostratus, then nimbostratus. Now behind the warm front, we now have the warm air moving to the south. There's generally clearing conditions with relatively warmer temperatures, but we now recognize that that in fact is an indicator of another approaching front, namely the cold front here. Now, as that air moves to the south into our region, it again intersects with the warmer air out ahead of it. And again, because the warmer air is less dense, it starts to rise up. Now the front, the structure of a cold front is much steeper than the warm front. And so the rising is much more rapid. And in this case, you don't get the nice layered clouds like you did ahead of the warm front. You get a very dramatic rising, cooling, and cloud formations along a cold front. In this case, what you're getting is cumulus clouds. And so along the cold front and behind the cold front, you have these billowing cumulus clouds. And if they're producing precipitation, that is what we would call cumulonimbus clouds. And then eventually, as the cold front passes us by, we have very cold air and clear conditions. So it's the combination of the movement of the air masses from one region to another, and then their intersection and the vertical movement up and over, in this case, the warm air moving up and over the cold air, that starts to produce the vertical movements that end up producing the cloud formations and eventually precipitation, either in the form of rain or snow. So there we have it. Now, based upon some of the basics that you've just seen, what we can start to do is use some of the changing weather conditions that accompany the traveling cyclone as predictors for what type of weather we might experience. And as I said, the whole driving force for the weather is the movement of air masses under the influence of the winds. So what we're actually going to use as our first predictor is wind direction. And so the first indicator of an approaching storm, as I noted, is the presence of easterly winds, a reversal of the typical winds from westerlies to easterlies. So when we have the easterlies or southeasterly winds, then indeed we have an expectation that there is an approaching storm and warm front. And so in this image over here, what we have is, again, the winds moving from the east or the southeast with the warm front here. And out ahead of it are, again, these cirrus clouds, then cirrostratus, fairly high up. But as the front gets closer and closer, we start to see altostratus. And if there's any rainfall, the nimbostratus there. So we expect that as the fronts approach, the clouds are increasing, or the cloud cover is increasing, and eventually we might get mild precipitation out ahead of the warm front. Now, what happens once the front passes us by? Well, then the regions are going to start to experience a southerly flow from the south. Now, as this air moves up from the south, what we expect is that, in fact, the conditions are going to clear. We're going to come under the influence of warmer air here. So we now have a southerly or southwesterly wind. The warm front is passed, but now the expectation is that there's going to be a cold front approaching soon thereafter. And so we expect warmer temperatures, but we also expect imminent weather from the cold front that's coming in from behind. And indeed, that's the last wind direction that we can use. Here is another image of a low pressure center. And now we're going to focus on the northerly winds coming from the north. We expect as the front comes into our region, the first thing we might experience is heavy precipitation. So if we were to turn to this image, again, this would be the southerly winds out ahead of the warm or the cold front, but behind that is this northerly winds that are moving into this region and pushing this air towards us. Here is the front, and you can see that it's fairly steep. And so as the air rises up and over that colder, the warm air rises up and over that colder air, we start to get these billowy clouds. And in addition, if the lifting is strong enough, we get the very heavy precipitation right along the front here, as well as behind it. Then, once we've gotten the cold or the northerly winds moving down, we expect that that's going to bring in much colder air, so the temperatures are going to drop rapidly. And what we expect eventually is that that's going to indicate that the storm system is moving out, and the winds will then revert back to typical westerlies behind the traveling cyclone. So the first and probably best indicator of an approaching storm is wind direction, because the wind direction drives the moving air. But we can also, as I've highlighted throughout, look at the accompanying cloud cover. So again, with the approaching warm front, the expectation is that out ahead of the warm front, we're going to have relatively high layered clouds, effectively cirrus and altostratus. As the warm front gets closer, we expect that behind will, in this region, start to have thicker clouds and eventually possibly nimbostratus clouds with precipitation along the warm front. And so as a visual for this, this is what we might see. And this is what your students might see as well. Out ahead, we have these sort of small layered high-level clouds. These would be cirrus and altostratus clouds. As the storm approaches, and the warm front's going to be over here, moving in this direction, they're starting to thicken and get lower, and eventually they form a cloud deck, again, a layered set of clouds. And then in this gray region here is where you would find the nimbostratus and precipitation. I would ask for questions. Usually if I was teaching, this is exactly where I would ask for questions. But you are all on mute. So if anyone wants to unmute and ask a question, I can certainly take it.
So one thing also, people can post questions in the chat.
Oh, okay.
And then I could read them if they, don't want to unmute.
I can't see the chat because I don't want it to cover up your screen.
Right.
Well, I can also continue and leave it till the end of the
Mm-hmm.
Okay, so we have, okay, so cloud cover for associated with the approaching warm front. Now, what about the approaching cold front? Well, in this region, far enough out ahead of the cold front, we generally expect, again, relatively mild conditions, relatively warm, not much cloud cover. But as this cold front approaches, we will start to see the first indications of that rising air. Again, because the rising is more, not more violent, but more rapid than in front of the warm front. We expect the initial clouds to be cumulus type clouds, so alto cumulus. And then eventually, right on the front, we expect to find the most rapid rising. So this is where we would find the cumulonimbus clouds. And then behind the front, under cold conditions, what we tend to find is much clearer cold air behind it as the cold air moves into our region. And so this would be a typical image your students might see associated with approaching cold fronts. Out here, high-level clouds, wispy, but some structure to them. Those would be the cirrus, and then these would be the altocumulus. But where we see this very rapid billowing of clouds, that would be the cumulus clouds, and this is the indication of very strong rain beneath those clouds associated with what we would call cumulonimbus clouds and heavy precipitation right along the front. So those would be the typical clouds your students might see as part of their globe measurements. Now, obviously, it's changes in pressure that are inducing the circulation. So in fact, we can measure pressure and changes in pressure as a measure of approaching storms, but it's a bit more nuanced and complex than you might expect. So in fact, if I were to pick the order in which you would want to measure things and use them for predictions, it certainly would be winds first, then it would be clouds, and then you could start to use pressures to augment those other measurements. So one thing we know is that for low pressures, we tend to have rising air, and rising air again leads to cloud formation and precipitation. High pressures tend to be associated with sinking air, and anytime air is sinking, this tends to cause the clouds to dissipate, leading to clear, dry conditions. So why is this? Because remember, for low pressures, we had air circulating around and into the low pressure centers. Now, at the surface, as this air moves into these regions, it has to go somewhere, and the only way it can go is up. Conversely, for high pressure centers, air tends to spiral out of the high pressure centers. Now, as that air spirals out of those regions, the replacement air is actually coming from above. And so that's why we tend to have sinking air that causes clouds to clear out. And so what we tend to find is cloudy conditions over the low pressure regions and clear conditions over the high pressure regions. So that's another weather phenomenon that's induced by the pressures themselves. Then the other thing we can look at is changes in pressure with time. So if you note, again, the typical movement of storms is in this direction. So if we were sitting out here in Michigan and we're measuring pressures, the first thing we might measure here is pressure of 1,014 millibars. But as the storm moves into our region, the pressures will start to drop to 1,012 millibars, 1,008 millibars, and so forth. So a dropping pressure is an indication of an approaching low pressure center, a traveling cyclone. Now, it turns out that the approach of fronts also brings falling pressures, whether it's the approaching warm front, or even if you're back here, as the cold front approaches you, pressures also continue to drop. So the only way to distinguish whether it's an approaching warm front or cold front is to look at the wind direction. Again, remembering that easterly winds tend to precede warm fronts and southerly winds tend to precede cold fronts. So while we're watching the pressures drop, we also have to be watching the wind fields. If the winds are coming from this direction, it indicates an approaching warm front. If they're coming from this direction, it means that the cold front is going to be moving into our region. Now, once the traveling cyclone moves out of our region, say if we're back here, then indeed the pressures start to increase. Say from 114 millibars initially, then as this air mass moves into our region, the pressures increase to 120, 123, and that's an indication that the storm system is moving out of our region. So let's put it all together. The way that we can do it both as within the weather forecasting community, but also as students, is through what we call a meteogram. These are graphics that show the changes in the local weather conditions at a given location. So in this image, there are 4 measurements: surface pressures, wind barbs or wind direction, temperature, and the other one that I'm going to focus on is precipitation. Now, as an aside, if you haven't seen wind barbs, they give both the indication and magnitude of or direction and magnitude of the winds. So the winds point in the direction of this arrow, with these being like the feathers of a tail of an arrow, and the amount of feathers tells you how fast. This represents 10 knots, this represents 5 knots. As we get further along, you'll see others that represent the sum of 5 and 10, 15, 20, 25 knots. Okay, so where are we? Let's...
Bruce, do you have a question from Tracy about what changes the pressure? Is it the temperature or the wind or both?
For the low pressure center?
I think that's what she's asking about.
Yeah. The easiest way to do it is this one. I will go all the way back here. It turns out that what changes the pressures down here is actually a phenomenon that's happening about 10 kilometers up here. It turns out that changes in the jet stream 10 kilometers up actually induce the vertical motions here and here. And so those changes, by effectively acting like a straw and sucking this air up, in turn produce, like a vacuum, a low pressure down here. As it turns out, similar changes in the jet stream up here can also produce descending air. They can also force air to move downwards. And so, in fact, this is like blowing through a straw. And by blowing through this straw, by pushing the air down, that's actually inducing the high pressures. So, in fact, the surface pressures are really a signature of stuff that's going on 10 kilometers up in the atmosphere. I won't go into that, but it's actually just a response to dynamics in the atmosphere in the jet stream some 10 kilometers up, either sucking air up and inducing a vacuum, or pushing air down and inducing a high pressure center here. You can ask if that suffices for right now. Yes?
Well, I don't know, but yeah, if Tracy says yes.
Okay. So, going on with the meteograms. So let's try and discern what's going on here. So it turns out in the time period, these are days, 1 day, 2 day, 3 days down here, we had actually a warm front pass through. The winds were from the south, and they were then from the north, and that was where the cold front air came in, and we're now in a nice pattern where the winds are from the west. The pressures have been rising, so in fact we had a cold front and warm front pass through, but now it's moved out, pressures are rising, but we're getting some indication from the pressures that they're starting to drop. And in addition, now the wind fields are starting to no longer be from the west, but in this case from the south and eventually the southeast. So there's going to be some expectation with this, the change in the pressures and the winds, in fact, a warm front is passing us by. And indeed, as we measure those fields over the next few days, what we find is that there was a passage of a warm front. Now we see that the winds are from the south and pressures continue to drop. And in fact, temperatures are starting to rise. So we had the passage of a warm front, and now there's an expectation that maybe a cold front is going to be moving into our region. If we continue to measure, what we find is pressures continue to drop as the cyclone approaches us. The wind fields are still from the south, and so the temperatures are continuing to rise, but we're just starting to see the signature of rain in this region, which is indicated by green. And sure enough, if we continue to measure, that's when we get the passage of the cold front. What we find is that there's a dramatic shift in the wind fields. The winds are actually now stronger, a dramatic drop in the temperatures, an increase in the pressures as the cold air is moving into our region, and accompanying that, the strong and heavy precipitation along the cold front. And now what our expectation is that in fact the storm system is going to move out. The weather is going to revert to sort of typical conditions. But if we continue to measure, now we find that the pressures are now dropping again. What was northerly winds have now become easterlies. And in fact, that's the expectation that another storm system is going to be moving into our region soon. With the dropping pressures, the switch of the wind fields to the easterlies signifying an approaching warm front. And in fact, that's what happens. The warm air moves in, or not the warm air, but the winds switch from easterlies to southerlies. That's the indication that the warm front has passed us by. But before that period, what we find is some lighter precipitation along the warm front. In this case, there was no cold front. The warm front associated with the air from the south has moved into our region, and then it just goes back to the westerlies and the pressures start to rise. So in fact, for this system, the cold front missed us, and this region was only influenced by the warm front. So that's how you would put it all together as you measure the changing wind fields, for instance, associated with the sort of mild conditions here, then the change in winds signifying approaching warm front, the change to these winds signifying the passage of the warm front and the approach of a cold front, and then these winds signifying the passage of the cold front, and soon there, or accompanying that, the heavy precipitation. So these are the types of measurements that you can take with GLOBE and hopefully make some type of prediction. Now I'm going to share, before I conclude, another set of slides. Stop sharing this. I will start sharing another one. So this is the most recent meteogram for Boston that I could find. It's not nearly as nice as the other one. This is temperature here. It's not very intuitive. These are winds. These are the wind barbs. In fact, in this case, they're giving sky conditions, and you might already be using these or get familiar with these indicators of sky conditions through GLOBE. It's partially clouded, partially cloudy, clear, mostly cloudy, and completely cloudy. This is sea level pressure, and this is time of day, or day. So this was the 18th, the 19th is here, the 20th. And so in fact, leading up to the approaching storm in Boston, we can see that there's northerly winds, relatively cold temperatures is the expectation, clear conditions, rising pressures, but now we're starting to see a reversal of the wind fields. We see that there's some indication of clouds moving into these regions, and we also see that there's falling pressures. So in fact, there's an expectation that there's going to be an approaching storm. Now, it's hard to gauge from this just how intense that storm is. In fact, that's the problem your students are going to run into continuously. Namely, that it is not easy to do local forecasts. Local forecasts are generally best for 24 hours to 48 hours out. And it's really, even for meteorologists, tough to do it much better than 1 to 2 days out, which is why we now use satellites. So this is what's approaching. If I can pull it up. There is an image of, in reds, cloud cover and storminess. The L right here, oh, I can actually, I remember, I can do this. I will draw with a fairly thick arrow. This is the low pressure center. Here is, oh, it turns out to be an occluded front. And here is actually, yes, and there is a cold front. This low pressure and this low pressure are going to merge as I move this forward. I want to get rid of my annotate so I can do this. So I'm going to just slowly move forward. So there's the low pressures. They're going to start to merge into one low pressure center, and I want to get rid of my annotations, so I will erase these. And so here is one large low pressure center now. And we can see that there's heavy precipitation along here. This is going to be the cold front, but there's also this cloud cover and precipitation in front of it, associated with, again, this warm air moving to the north. And if we continue to move forward in time, we're going to watch that thing move northward. And in fact, here is the most recent image. So here's the low pressure center. The expectation is that the winds would be flowing from the east to the west. So in Boston, we'd be receiving easterly winds. We'd be seeing some of these clouds right now. Now, it was mentioned that people in Florida are already experiencing very heavy precipitation associated with this cold air moving down, creating a very strong cold front right here with heavy, heavy precipitation along it. And for our region, as this continues to move north and the winds come off the ocean laden with moisture, that's where we get what we call a nor'easter. Winds from the northeast bringing cold, moist air into our region that produces heavy, heavy precipitation. So you can see that it's much easier to track this movement with satellites than it is locally, but those are the features that are accompanying the movement of this traveling cyclone across the mid-Atlantic states, producing weather both all the way down here in Florida, but eventually all the way up here in the Northeast. So to conclude, I just want to say that by taking globe measurements continuously with your students, you actually have lots of learning outcomes that you can meet. You can start to describe and classify things, namely the observed weather and its day-to-day changes. You can produce tables and graphics to display these changes. You can start to develop models based upon the students' knowledge of the circulations and the weather that accompany these traveling cyclones. And you can then use these models to make predictions about future changes in the students' local weather of and the weather of your area. So hopefully, as the students move up through the various grades, they can actually start to address all of these learning outcomes through the globe measurements. So I will conclude there. I will stop sharing, and I will let people ask questions or clarification.
Sure, and so thanks, Bruce. That was really good. So I wanted to, Tracy posted, you mentioned that Florida and Texas don't get this weather pattern. Why is that?
I will clarify and say that they do. they are now getting, somebody mentioned that they are now getting hit by it current. So in this, can you see this image? No.
Not yet.
Not yet, sorry. So I showed the image from today where Florida is getting hit by weather induced by this traveling cyclone. You can see something similar in this image, which is a historical image. Again, the traveling cyclone would be right here. The low pressure center would be right here. There would be this massive movement of air to the south, forming a cold front, and I can guarantee all along this cold front, Florida is getting battered by high winds and heavy precipitation. So the only reason I isolated Florida, Texas, and sometimes California is that not only are they under the influence of these mid-latitude traveling cyclones, which influence the rest of the regions, we also recognize that, in fact, Florida is also influenced by the presence of these things. Those are called tropical cyclones or hurricanes, and they move in this direction, as we're probably all familiar with. So the only reason to isolate Florida, Texas, and California was to highlight that, in fact, their weather can also be a response to tropical phenomenon, not just what we call mid-latitude or traveling cyclones. But they certainly are impacted by these traveling cyclones as well.
Mm-hmm. All right, well, thanks for that. And Sarah posted that she'd like to have the website that you just had with the weather analysis. Can you post that website in the chat box?
The website currently, yes, I can. If I can figure out how to, I can cut it. Now I just have to figure out how to chat with you guys.
Yeah, so chat should be on the lower part, right next to the share screen, the little box there.
Okay, here we go. There it is. That will get you the video. That's why it says, you can't see it. That says SFC Loop. That stands for Surface Loop. Mm-hmm. Let me go back one. And there are a whole slew of additional surface products available at that site. So if you go to that site, you will see that you can pull up maps with radar images, maps with satellite images, maps for the eastern US, maps for the western US. You can pull up maps that just show the fronts. You can pull up maps. I guess I'll share a screen just to emphasize this. Share screen. What you'll see is something that looks like this. It'll start with this, but if you scroll down and you go and ask, okay, can I see the satellite composite for North American Pacific? If you're in California, this is what you care about because you want to watch the storms moving in from the Pacific. And right now, California is about to get clobbered by a low pressure center that's moved in from the Pacific. So this is our storm. This is the one that's impacting California. But if you scroll down, you can start to see things that have radar instead of satellite images. So here is the radar images of precipitation that's moving through the mid-Atlantic states and is going to move into California. Here is the radar precipitation that people in Florida are experiencing. Here is the radar image of the heavy precipitation in California. So this site will allow you to pull up a whole bunch of these different types of images for central US, eastern US, and so forth.
All right. Oh yeah, so Sarah said that she lives right on Lake Erie, and we're having flooding along the western side of Lake Erie because of the strong easterly winds today. I actually had a situation where I was driving on the highway back from Defiance, Ohio, into the wind, and my pickup truck is a 2001 with not a lot of get up. And I was actually had the pedal to the floor, and I was still losing speed at times because of the oncoming wind was so strong from the east.
So I'm not sharing this with you. Here's another image from that. It's not a great image, but share screen from that website. So here's the low pressure center again. If you can see my my cursor, but the winds that you are feeling are the ones that are circulating around here and blowing very strong between this low pressure center to the south and this high pressure. And where these isobars, these lines of equal pressure, are very compressed, that's where you find the strongest flow. And so that's exactly what you guys were running into.
And Neusa, she asked about if anybody has 3rd to 5th grade resources. So teaching this to the younger students.
Well, we put third, that is actually BU's. That is BU's directive, is to start putting together the GLOBE learning modules for the elementary students. And I did quite a bit of that. Now I'm trying to remember just what was atmospheric protocols and cloud protocols versus what was weather prediction protocols. And whether there's anything that's going to be at the 3rd to 5th grade level for these types of weather prediction, I can't recall right now, but I can also look it up. So Monday or Friday at 1, I have an opportunity I might try and pull together those resources.
Okay. All right, do we have other questions for Bruce? So we'll do a dramatic pause.
Well, there's somebody just recommended AMS.
Okay.
For those who don't know, AMS is American Meteorological Society. So.
And also GLOBE has the GLOBE books, right? The elementary GLOBE books, which may be of use. There's the atmosphere one, clouds, and aerosols. Now, they're technically not weather prediction, right? So it's kind of the first steps of observing the clouds, that type of thing. Trying to think.
Well, we've certainly taken the tack that this has to be vertically integrated, that what they'll be learning in 1st, 2nd, 3rd may not be weather prediction, but it will certainly be setting the stage for 4th, 5th, 6th, 7th, where they can start to implement some of this knowledge in a synergistic way that allows them to start doing these types of predictions. And from there, eventually get to posting the data, downloading the data, looking at the satellite images and so forth. So it's definitely a vertical integration of the knowledge across the grades that's going to get them to that point.
Okay, so Vakele sent a message to me privately, maybe not to everybody, but here's the question. Is there any driving force that caused wind to move clockwise and anti-clockwise between these two pressure systems?
The rotation of the Earth. Were the Earth not rotating, air would just move right into a low pressure center and right out of a high pressure center. But because the Earth's rotating, the air does not actually move directly into and directly out of high and low pressure centers. It in fact does this spiraling. And so it's actually a combination of the pressures that induce the movement of the air, but then as they move over the rotating Earth, they assume this rotation about the pressure centers. And so you always get moving air moving clockwise air moving into a low pressure center and out of a high pressure center. But in the northern hemisphere, it's counterclockwise into a low pressure center. And in the southern hemisphere, it's clockwise into a low pressure center, because the sense of rotation in the southern hemisphere is opposite the northern hemisphere. So it's a combination of the presence of the pressure centers plus the rotation of the Earth.
Right, the Coriolis effect.
There you go.
Yeah. And I don't know which hemisphere Cayley is in, but yeah, so you could be northern or southern. All right. Well, I'll wrap it up here and go on to show you the next, so everybody, the announcements. Let's see if I got this going here. Okay. So as I mentioned earlier, the students follow-up will be Friday at 1 o'clock Eastern Daylight Time. And so here's the URL for that. All right. And then we have another, our next webinar will be April 10th, 8 p.m. Eastern Daylight Time again. So Susan Hassal, I'm not sure how to say your last name, but is the Director of Climate Communications, and she'll be talking about climate. And then she'll have a Friday follow-up as well. So that should be great. I'm looking forward to that. And just a few announcements. Don't forget, register by April 11th for the University of Toledo Satellites Conference. That's May 1st. And then the regional Globe Symposia are coming up for students to present their research. I think, yeah, so the registration dates are here, and then the dates of the symposia are listed. If you know someone who's a career technical education teacher, so this is shameless plugging, I guess. University of Toledo, we have our teacher training June 11th through 15th. And so career technical teachers could sign up. And then here's all of our social media links. All right, including our monthly webinars. All right, stop sharing. Oh, and Sarah says, please like Globe Mission Earth on Facebook. Yeah, so if you go to Facebook, type in Globe Mission Earth, and you'll get, you can like us, and then you'll get all these announcements. Well, Bruce, I want to thank you for a great webinar and very insightful about using the clouds and wind direction to predicting the weather and how the storms are moving. And I want to thank everybody for tuning in. And I hope you join us next time. And Friday, don't forget Friday at 1.
Yes. Well, thank you everyone for joining in as well. I really appreciate the time.
All right, have a good night, everybody.